Our universe is a strange and wonderful place. The laws of physics, as we know them, break down at the smallest scales. Particles, the building blocks of everything around us, behave in ways that seem impossible. They can be in multiple places at once. They can be both waves and particles. They can even be connected across vast distances. This is the realm of quantum physics, a world that is as baffling as it is beautiful. Imagine a world where a single object can be in two places simultaneously. Imagine a world where light behaves as both a wave and a particle. This is the reality of the quantum realm, a place where the familiar rules of classical physics cease to apply. It is a realm of probabilities and uncertainties where the very act of observation can influence the outcome of an experiment. Quantum physics challenges our fundamental understanding of the universe. It tells us that the world is not as deterministic as we once believed. Instead, it is a place where chance and probability reign supreme. But within this uncertainty lies a profound beauty, a glimpse into the fundamental nature of reality itself. In our macroscopic world, we are accustomed to predictability. A ball, when thrown, follows a predictable path. A dropped object falls to the ground. But in the quantum realm, this predictability vanishes. Particles behave like mischievous sprites, their actions governed by probabilities rather than certainties. Imagine flipping a coin. You know the possible outcomes, heads or tails. But until the coin lands, you can't be certain of the result. This is analogous to the behavior of quantum particles. We can predict the probability of a particle being in a certain state, but we can never be entirely sure until we observe it. This inherent unpredictability is not a flaw in our understanding. It is a fundamental aspect of the quantum world. It tells us that the universe is not a giant clockwork mechanism, but a dynamic and ever-changing tapestry of probabilities. One of the most mind-boggling concepts in quantum physics is wave-particle duality. This principle states that particles like electrons and photons can exhibit properties of both waves and particles. This duality is beautifully illustrated by the famous double-slit experiment. Imagine shining a beam of light through two narrow slits. Classical physics predicts that we would see two bright bands on a screen behind the slits, corresponding to the light passing through each opening. However, the double-slit experiment reveals a far more intriguing result. Instead of two bands, we observe an interference pattern, a series of bright and dark fringes, as if the light were interfering with itself like a wave. Even more astonishingly, this wave-like behavior is observed even when we fire single photons one at a time through the slits. It's as if each photon somehow travels through both slits simultaneously, interfering with itself to create the interference pattern. This experiment fundamentally challenges our classical intuition about the nature of light and matter. Two other cornerstones of quantum physics are superposition and entanglement. Superposition suggests that a particle can exist in multiple states simultaneously until it is measured. This is like a coin spinning in the air, being neither heads nor tails until it lands. Imagine a cat inside a box. This cat, according to quantum mechanics, can be both alive and dead at the same time until we open the box to observe its state. This thought experiment, known as Schrödinger's cat, highlights the paradoxical nature of superposition. Entanglement, on the other hand, is the idea that two particles can be linked, even when separated by vast distances. When we measure the state of one entangled particle, we instantly know the state of the other, regardless of the distance between them. This spooky action at a distance, as Einstein famously called it, has been experimentally confirmed and has profound implications for our understanding of the interconnectedness of the universe.